This is section 5.1, part 7. We're on our second exploration on multiplicity, and we're actually going to summarize what we saw on the other in the last video. Using the graph in 8c, record below the difference in the graph at zeros of even and odd multiplicity. So here's our fact. If r is a zero of even multiplicity, numerically, the sign of f of x does not change from one side to the other of r. So what that means is, since we touch, if it's even, remember we said even touches, so the sign of y, if we're above, we're still above, if we're below, we're still below when we touch, right? So the sign doesn't change. Graphically, the graph of f touches the x-axis at r. If r is a zero of odd multiplicity, the sign of f changes from one side of the intercept to the other, right? Because we're crossing. The graph of f crosses. So you're going from either negative to positive or positive to negative. Now let's talk about turning points. The turning points theorem says a turning point on a graph is a point where the function changes from increasing to decreasing, or vice versa. These points are the local maximums or local minimums of the function. An example of a turning point is the vertex of a parabola. In the vertex, you're turning. You're a turning point where you're changing from increasing to decreasing or decreasing to increasing. In the parabola, y equals x squared, the degree of the polynomial is 2, and there is how many turning points in just a regular parabola y equals x squared? Just one, right? That one turn, right? Or turn. In general, if f is a polynomial function of degree n, then the graph of n has at most n minus 1 turning points. And likewise, if the graph of a polynomial function has n minus 1 turning points, the degree of f is at least n. Two ways to say the same thing. So it's at most. So when it's degree 2, the most turning points is 1. If it's degree 3, the most would be 2. It may not have 2. If it's degree 3, it may not have 2. The most would be 2. Okay, so let's look at this example for turning points. Example 9, state the degree and the number of turning points for f of x equals negative 2 times x minus 2 times x plus 1. So we've got to figure out the degree of this polynomial first. Do we have to multiply that all out to figure out the highest power on x? If we did multiply it out? No. You know, if you FOIL these and then multiply by negative 2, the highest power is going to be what? 2, right? So n equals 2. In other words, the degree is 2. Our highest power would be 2. And turning points, n minus 1 or 2 minus 1 or 1. There would be one turning point. Okay, we'll continue in the next video.